Hello friends, today I will be giving my presentation on the topic program development steps, programming paradigms, object-oriented programming, structured programming and functional programming. Hi, I am J. Durga Prasad Rao, PhD Computer Science and also HOD Computer Science from Shri Shankaracharya Mahavidyalaya, Junwani, Bhilai. Apart from that, I am also additional director of the college. The topic which I have chosen comes under Unit 4 of the subject Introduction to Software of class PGDCA, and this PGDCA comes under the Hemchand Yadav Durg University. So let's begin. Programming development cycle. We'll be looking about how to define the problem. Well, you have to do careful reading of the problem. We are not focusing on solution, but a part of the solution. Then you have to analyze the problem. That means determine all possible solutions, select the best from them. If you can break the whole problem into sub problems or sub parts, then it will be more easy for us to deal with the problem. And then design the solution. That means create an outline on how program should be executed, expand it into certain steps, that is algorithms, which describes the order of tasks to be carried out. Then code the program. Begins only after we have clear idea about algorithm of the solution. We can use appropriate language and editor to write the code. Compilation of the code, find the syntax and semantic errors. Compilers and interpreters of corresponding language can be used. If error occurs, we need to change the code to solve problems. After successful compilation, object code is generated that a machine can understand. Then linking of the object code. Linker links the libraries and object code then and puts all objects into correct order in the executable format. If error occurs during linking, then it might be problem in writing code of the linking. Loading of the programs. Loader loads the program into main memory and controls is passed to the processor. Loading includes reading an executable, checking permission, initializing registers. And final execution and testing. Execution of program is done by the processor. Debugger can be used to trace the error. We verify the output, and if the desired output is not achieved, we need to revise the whole process once again. Now this is the image from a program development cycle. Problem analysis, algorithm design, coding, compilation, linking, loading, execution and results. And if an error happens at compilation, during compilation process, then it has to be recoded again. Similarly, if error happens at linking, then it has again to do with the errors. And finally, if there is logical errors, a logical execution of the problem is not being done, then again it has to be recoded. Library is always available to help the linking program. So what is programming paradigm? A programming paradigm is fundamental style of computer programming. Paradigms differs in the concepts and methods used to represent the elements of a program, and also steps that comprise a computation. Let's go to history. Different approaches to programming have been developed over time. The concept of programming paradigm comes under a date at least from 1978. The lowest level programming paradigms and machine code. In 60s, assembly language were developed, followed by development of procedural languages. Following the widespread use of procedural language, object-oriented programming languages were created and followed by many more. Imperative programming paradigm. Imperative programming is a programming paradigm that uses statements that change a program state in much the same way that imperative mode in natural languages express commands. An imperative program consists of commands for the computer to perform. Imperative programs describe the details of how the results are to be obtained. How means describing the inputs and describing the outputs are produced. Some of the examples include Java, PHP, Python, C++, C. Declarative programming paradigm. Declarative programming paradigm is a programming paradigm, a style of building the structure and elements of computer programs that expresses the logic of computation without describing its control flow. Declarative programming focuses on what the programming should accomplish. Declarative programming often considers programs as theories of formal logics and computations are deductions in that logic space. Some of the examples include SQL, XQL, etc. Functional programming paradigm. Functional programming is a subset of declarative programming. Programming written using this paradigm uses functions, blocks of code intended to behave like a mathematical functions. Functional languages discourage changes in the values of variables through assignments, making a great deal of use of recursion instead. Object-oriented programming paradigm. Object-oriented programming, or OOP, is a programming paradigm based on the concept of objects which may contain data in the form of fields, often known as attributes, and code in the form of procedure, often known as methods. There is a significant diversity of OOP languages, but the most popular ones are class-based, meaning that objects are instances of class, which typically also determine their type. In OOP, computer programs are designed by making them out of objects. Some of the example includes PHP, Python, Gas, Java. Multiple paradigm. A multiple paradigm is a programming language that supports more than one programming paradigm. The design goal of such languages is to allow programmers to use the most suitable programming language style and associated language constructs of a given job. Languages such as Java, Python, and multi-programming languages that support object-oriented language to a greater or lesser degree, typically in a combination with imperative procedural programming. A glance of different paradigms. Imperative, which we already discussed, programs as statements that directly changed computed state. Functional treats computation as the evaluation of mathematical functions avoiding states. Object treats data fields as objects manipulated through predefined methods only. Declarative defines programming languages but not detailed control flows. Examples could be SQL, CSS for declarative, C++, C hash for object oriented, C++, Lisp for functional, and C++, C, Java, PHP, Python, Ruby for imperative paradigm. So in a conclusion, we can say there is still not a consensus on a programming paradigm and programming language is most suitable. All approaches have their advantages and disadvantages, with many supporting arguments and case studies. Despite that, it seems that nowadays the most popular paradigms are introductory courses are the procedural with programming languages C, and procedural part of C++, the object oriented with the languages Java and C++. Introduction. Object-oriented programming is the principle of design and development of programming using modular approach. The basic element of object-oriented programming is the data. The programs are built up by combining data and functions that operate on the data. Some examples could be C++, Java, Perl, Python. Procedural programming. Procedural programming focuses on processing of instruction in order to perform desired computation. The top-down concepts to decompose main functions into lower level components for modular coding purpose. Therefore, it emphasizes more on doing things like algorithms. This technique is used in a conventional programming language such as C and Pascal. Object-oriented programming. Object-oriented programming is a concept that combines both the data and functions that operate on that data and to a single unit called object. An object is a collection of a set of data known as member data and functions that operate on these data is known as member functions. OOPS follows bottom-up design technique. It's the major concept that plays important role in this approach. Class is a template that represents group of objects which share common properties and relationship. So here are the certain differences between procedural programming and object programming. Large are divided into smaller programs known as functions. Programs are divided into objects. Data is not hidden and can be accessed by external function. Data is hidden in object-oriented programming and cannot be accessed by external functions. Follow up top-down approach in the programming design. Here, OOPS, it follows the bottom-up design. Data may communicate with each other through functions. Objects may communicate each other with through functions. Emphasizes on procedure rather than the data. Emphasizes on the data rather than the procedure. Objects are basic building blocks for designing programs. An object is a collection of data members and associated member functions. An object may represent a person, place, on table of data. You can see the image in the slide. Each object is identified by a unique name. Each object must be a member of a particular class. Now, what is actually class? A class is a collection of objects that have identical properties, common behavior, and shared relationship. Object can be made user-defined data types with the help of a class. Now, once a class is identified by a number of objects and the class is created, classes are user-defined data types. A class can hold both data and functions. You can see from the image. Example could be sun, moon, and member of class solar system. So now let us learn about data abstraction, encapsulation, data heading. Data abstraction refers to the process of representing essential features without including background details or explanation, whereas encapsulation is the wrapping of data and functions into a single unit or a class is called data encapsulation. Data encapsulation enables data heading and information heading. Data heading is a method used in object-oriented programming to head information within the computer code. You can see the figure image of a capsule and how encapsulation is explained in those data. Inheritance. Inheritance is the process by which one object can acquire and use the properties of another object. The existing class is known as base class or superclass. The new class is known as derived class or subclass. The derived class shares some of the properties of the base class. Therefore, a code from base class can be reused by the derived class. Overloading. Overloading allows objects to have different meaning depending upon context. There are two types of overloading: operator overloading, function overloading. When an existing operator operates on a new data type, it is called operator overloading. Function overloading means two or more data have the same name but differ in the number of arguments or data types of arguments. Polymorphism, the ability of an operator or function to take multiple forms, is known as polymorphism. The different types of polymorphisms are operator overloading and function overloading. Dynamic binding and message passing. Dynamic binding is the process of connecting one program to another. Dynamic binding is the process of linking the procedure to a specific sequence of code or function at a runtime or during the execution of the program. OOPS processing is done by sending messages to object. A message for an object is to request for execution of procedure. Message passing involves specifying the name of the object, the name of the functions, and information to be sent. Some advantages of the OOPS include the programmings are modularized based on the principles of classes and objects. Linking code and object allows related objects to share common code. This reduces code duplication and code reusability. Creation and implementation of OOPS code is easy and reduces software development time. The concept of data abstraction substrates object specification and object implementation. Data encapsulated with the functions. Therefore, external non-member function cannot access or modify data, thus providing data security. Easier to develop complex software because complexity can be minimized through inheritance. OOP can communicate through messages passing, which makes interface description with outside system. It also has certain disadvantages. Large programming size, slower programs, not suitable for all types of programs. To convert a real world problem into a object oriented programming model is difficult. OOP software development, debugging and testing tools are not standardized. Polymorphism and dynamic binding also required processing time due to overload of functions calls during the runtime. And some certain application of OOPS includes computer graphics application, CAD/CAM software, object-oriented database, user interpreters designed such as Windows. They can also be used in real-time. Simulation and modeling is also benefited by OOPS. Artificial intelligence and expert systems have their own way of using OOPS, and then they are highly recommended for client-server systems. So that's all for today's lecture on the topic which I'd already mentioned in the first slide. And given my Gmail address in the first slide. If any of the learner of any category finds it useful or have any query, they can contact me through mail address, and I would be happy to help you out. Thank you very much.